Good morning. Today we are going over some more similar polygons. There are parts of this notes that I'm going to skip around and skip over because these notes are super duper long, but I want to kind of get straight to the point and hopefully it's just things that you will see in the future on tests and quizzes and stuff like that. So I just kind of want to get straight to the point and get you to understand those things before we move on to indirect measurements for the next chapter. Okay. So we're just still doing more similar polygons. So biggest thing is that if I highlight it, I want you to write it in your notes if you're at home. But so the two things that we need to go over, make sure that we understand, because this is what we learned last unit. If two polygons are similar, then their corresponding angles are congruent and their corresponding sides are proportional. Okay. I do want you to draw these right here, these little figures. Okay, because we're going to use those to find scale factor. But first, let's go over scale factor. What scale factor is a ratio of any two corresponding lengths in its simplest form. All right, so biggest thing, it's just a fraction between the side lengths that are corresponding to each other. So yesterday, or the last video, we talked about which sides are corresponding, which parts are corresponding, and then the time before that, we learned what a ratio and a proportion is. Today, we're going to combine those together. Okay, so if we are wanting, so example 2 says, what is the scale factor of the quadrilateral ABCD to quadrilateral EFGH? So that tells us right there what order we need to go in. Okay, when it says what is the ratio from this to this, it tells you exactly what goes on top of the ratio. So because it said quadrilateral ABCD first, ABCD is going to go on top of the ratio. Okay. So the scale factor of ABCD to EFGH, and what is that? So again, a scale factor is just a ratio between two corresponding lengths to its simplest form. So in this question, when we use these pictures right here, every side is present, but that might not always be the case in further examples that we'll do in this video. So what you have to do is pick the two corresponding sides that you do have. Well, in this case, we have all of them, so we can just pick. So I'm going to pick 10 and I'm going to pick 5. Okay, so because ABCD goes on top, we are going to put 10 over 5. So there's our scale factor. But our scale factor isn't a scale factor until it's in its simplest form. So 5 can go into each of these numbers evenly. So we're going to divide both of these numbers by 5. So when we divide 10 by 5, you get 2. When you divide 5 by 5, you get 1. So the scale factor here is 2. Okay. So example 3 says show the ratio of the perimeters and is the same as the scale factor. So when we take the scale factor or when we take the perimeter of each of those quadrilaterals, when we simplify it, it should get us the same scale factor. So let's do that. So we have 10 plus 8 plus 6 plus 5, which is all the side lengths of ABCD. And we're going to put it over 5 plus 4 plus 3 plus 2.5, which is all the side lengths of EFGH. So when we add 10, 8, 6, and 5, we should get 29. And when we add 5, 4, 3, and 2.5, we should get 14.5. And when we simplify that, we get 2 over 1, or just 2. Okay? So everything, when two polygons are similar, all of its aspects, perimeter, side lengths, they all jump by the same scale factor. Okay, they all jump by the same scale factor. So if I were to flip it, so this says, what is the scale factor of quadrilateral EFGH to ABCD? Well, now EFGH goes on top and ABCD goes on bottom. Guys, nothing changes. Nothing changes at all. You just flip it, okay? So the numbers don't change, okay? But now instead of going from the ABCD to EFGH, now we're going to go from EFGH to ABCD. So now the ratio is 5/10. Which then simplifies down to 1/2. So the scale factor is flipped. When you flip the actual wording and you flip the word ratio, depending if you go from the big polygon to the little polygon, and if you wanted to change it to the little polygon over the big polygon, you just flip the numbers. All right, so let's do this example right here. It says determine if the figures are similar. Okay, so in order to determine if figures are similar, what you have to do is figure out if their scale factors are the same. So how we do that is we're going to match the sides. Okay, so 9 and 6 go together. 3 and 2 go together. And 18 and 12 go together. Okay, so we match the sides. We're now going to create ratios with those side lengths that are corresponding. So, or create scale factors. Okay, so we have 9/6. And I'm going to go from the big triangle to the little triangle. You can go from the little to the big. That's fine. Just as long as you stay consistent with every single ratio that you create. Okay, so I go from 9 to 6. We're going to go 18 to 12. And then 3/2. Okay. Our last step is to simplify. Just like you would when you're finding the scale factor, which that's exactly what we're finding is scale factor. Okay. We're going to simplify these ratios. Well, 9/6. 9/6, their greatest common factor is 3. So I can divide both numbers by 3 to simplify it to its simplest form. So when I do 9 divided by 3, I get 3. When I do 6 divided by 3, I get 2. Okay, so 9/6 is 3/2 in its simplest form. Then we have 18/12. Well, its greatest common factor is 6. So I can divide 18 by 6, and it equals 3. And 12 divided by 6, which equals 2. And that's in its simplest form. And 3/2 is already in its simplest form. So because all of these are the same, the scale factors are the same, these triangles are similar. Okay, so because the scale factor is the same, these triangles are similar. And this is a great way to just practice finding scale factor too. So you found that the scale factor from the big triangle to the little triangle is 3/2. Okay. All right, so let's do this problem right here. All right, use the similar figures below to answer the questions that follow. Quadrilateral EFGH is similar to quadrilateral ABCD. Okay. That just gave us our statement too. So this means that when we go to find scale factor right here, when we go to find scale factor, it needs to be EFGH over ABCD. Okay. So what is the scale factor here? Well, remember, scale factor is a ratio between two corresponding sides. So we need to figure out which two corresponding sides we have. Okay. Well, we have an x here, so we can't use 16 right now. We have a z here, so we can't use 5. And we have a y here, so we can't use 3. So the only two values that we have that we can use are 10 and 2.5. So because it's EFGH over ABCD, my ratio, my scale factor is 10 over 2.5. Okay, we need to put this in its simplest form. So 10 divided by 2.5 actually gets us 4 over 1, which is just 4. So our scale factor here is 4. Guys, finding the scale factor is half the battle. If we can find scale factor, we'll be able to determine our missing side lengths, okay? So with that being said, we want to find x, y, and z. And how you do that is using scale factor. So remember from the first video of chapter 6, we learned what the difference of a ratio and a proportion is, and being able to find missing parts of proportions or using proportions to find missing parts of ratios. Okay, that's what we're going to do here. But our first ratio will always be scale factor. Okay, so let's find x. So the biggest thing when finding a missing value, we have to figure out, okay, what is its corresponding side? Well, x, its corresponding side is 16. So remember, it's always going to be EFGH over ABCD. Okay, so let's make sure we're staying consistent in that way. So we're going from purple to blue. Okay, so EFGH to ABCD. So again, the scale factor always comes first. So when we're finding x, scale factor is always going to be our first ratio. Because these figures are similar, the scale factor between every side is going to be the same. So that's why we use scale factor as our first ratio. So 4 over 1 is our scale factor. So that's what we're going to use. And we're going to set it equal to the side part we're going to try and find and its corresponding length. And remember, it's purple over blue. So because I'm trying to find x, I need to pair it with 16. But remember, it's bigger to little. So then we're going to do 16 over x. So staying consistent with the ratio is also like a quarter of the battle. If we can't get that right, guys, it's going to be hard to be correct. Then we just cross multiply. So we have 4 times x, which is 4x, equals 16 times 1, which is 16. And then we divide by 4. So x equals 4. All right, so let's find y. All right, again, we're going to use scale factor. So 4 over 1 is our first ratio. Okay, I'm trying to find y. Well, y belongs right here and on FG. And the side that's corresponding with FG is BC, which has a value of 3. Okay, so I need to set it equal to its proportion with the missing side. So remember, since it's purple over blue, or EFGH over ABCD, it's going to be y over 3. And then we cross multiply. So y times 1 is y, and 4 times 3 is 12. So y equals 12. Okay, so now let's find z. Again, z. Okay, and z corresponds with 5. Okay, that is its corresponding side. So when I go to find z, I need to use my scale factor and set it equal to the missing part and its corresponding side. But remember, we're going from purple to blue, so bigger to smaller. E, F, G, H to A, B, C, D. So because 5 is on the purple one, 5 goes on top. And then Z goes on bottom. And then we cross multiply. So 4Z equals 5. Well, then we divide by 4. So Z equals 5 over 4. Okay. The next question says, what is the ratio of their perimeters? I'm not going to go over this, but once you add all of them, they should be the same. Okay, they should be the same answer when you get to that. So what you would do, you would add X, which is 4, Z, which is 5.5 over 4, or 1.25. And then you would add all to 3 and 2.5, add those all together, and put it in a ratio with 5, 16, 10 added together, and 12. And then you put them on a ratio. So you would put E, F, G, H over A, B, C, D. Okay, we're going to skip that one. We're going to do example 8, but we're only going to find scale factor and finding the following. So we're going to do this one and this one. We're not going to find the values of the angles. But remember, when we have similar polygons, the angles add up to, and not add up, they are equal to each other. So the course, so because A and E are corresponding, E is also 60 degrees. Just kind of clarifying that. Okay, so because quadrilateral ABCD and quadrilateral EFGH are similar, it's going to be ABCD over EFGH. Okay. Well, we got to pick two sides we have, and right now we have 6 and 18, so it's going to be 6 over 18, which simplifies down to 1/3. I know I'm going fast, but I also don't want you here forever. Okay, so our scale factor is 1/3. So when we're trying to find EH, BC, and AB, you're going to use 1/3. Now, I'm not going to complete these questions, but I am going to leave the answers in the description below. Okay, so you're finding EH, BC, and AB. So remember, scale factor comes first in your ratio. So 1/3 equals, and then you do, so 5 over X. That's the only proportion I'm going to give you. But 1/3 is always going to be your first ratio. And remember, you set it equal to the missing side and its corresponding side, okay, in a ratio. All right. All right, this is the last one I'm going over. So if the lengths of a side of a triangle are in a ratio, this is just a different kind of ratio question you will see. And these should be super simple. So you just take the ratio that it gives you. So it says the lengths of the side of a triangle are in a ratio of 3, 5, and 7. Its perimeter is 120. Find the length of the shortest side of the triangle. So all you really have to do on this, you don't even have to draw a picture for this. What I want you to do is take the ratio of 3, 5, and 7 and set it equal to its total. And its total, because we're talking about side lengths, is 120. So after you have realized that the ratio shall equal the perimeter, what we're going to do is multiply X by every single part of the ratio. Because let's be honest, 3, 5, and 7 is the ratio. It is simplified down to that, meaning that its greatest common factor is the same. So remember when we, and this might be confusing, but remember when we found the scale factor in this question right here, we divided by a number. Okay, we divided by a number that can simplify down to this. We divided by a number that can simplify down to this. That is the same thing here. These numbers were divided by a number, by the same number to simplify down to 3, 5, and 7. So we have to figure out what that number is. So in order to find the length of the shortest side. Okay, and that might have been confusing, but all you really have to do is step 1, multiply by x. So multiply the ratio by x. So we have 3x, 5x, and 7x, and then all we do is combine like terms and divide. So we have a 3x, a 5x, and a 7x. So 3 plus 5 is 8, and 8 plus 7 is 15. So we have 15x equals 120. And then in order to find x, we divide by 15. Okay. Alrighty. So x equals, and I don't know what... 8. So x equals 8. So the value of x is 8. So if we're trying to find the length of the shortest side of the triangle, we're going to multiply 8 by 3 because that's the smallest part of the ratio. So 3 times 8, which is 24. So the length of the shortest side of the triangle is 24. Okay, so I want you to try this one as well, the measure of the angles in a triangle. Angles, okay? So if it's angles, remember all the angles in a triangle add up to 180 degrees. So if the ratio is 1, 2, and 3, so it should be 1x plus 2x plus 3x equals 180 degrees. All right. I know this is long. I'll put the answers to this one in the description and the answer to this one in the description as well. All right. Bye, guys.